Hello and welcome back to the Gravity Doctors. I'm Dr. Lachlan Kent, and we have Brennan here with us today as well, plus a special guest, Professor Elisa Ferrè, who's a cognitive neuroscientist and a world-leading expert in the vestibular system. And she has a very deep expertise in this topic that Brennan and I don't have. So we learned a lot from this discussion. We hope you do too. And not just academically and intellectually, but there are, sort of facts that come out that really bring the lived experience of biogravitational medicine to bear. So here we go.
All right, so hi everyone. I'm Elisa Ferrè, and I'm a professor in cognitive neuroscience here at Birkbeck, University of London. And my background is indeed in cognitive neuroscience, and in particular in vestibular neuroscience. So I'm absolutely fascinated by the vestibular system, which is this tiny, small, sophisticated organ inside your inner ear, which detects each movement of your head in space and translate the movement in linear and angular acceleration. So I love this system. I'm obsessed with this system, and I'm particularly focusing on one feature of this system, which is the gravity detection. What else do I do here? So I'm a professor in cognitive neuroscience. I'm director of the Vestibular and Space Neuroscience Lab at Birkbeck, where we are running our research. Obviously, it's downstairs in the basement. And I'm also head of School of Psychological Sciences here at Birkbeck. That's me.
Very good. And how did you become interested in the vestibular system? What was your trajectory into it?
I got interested in this system pretty much during my PhD. So my PhD was focusing on vestibular multisensory integration. So the vestibular system is unique. It's completely different compared to all the other sensory modalities because it doesn't project to a unimodal, what we neuroscientists call unimodal primary cortex. So let's think about vision. So visual information from the eye, they project directly on some area in the brain that are visual specific. They are kind of visual only. So this visual only is what we define as unimodal. Same is for touch. The same is for auditory signaling. For the vestibular system is totally different. There is not one single unimodal vestibular areas, but rather there is a full network of many different areas that receive vestibular information. So during my PhD, I was studying vestibular and visual interaction, as well as vestibular and somatosensory interaction, and looking into this well-defined model of interaction in animal brain, but now focusing on human brain, because I only do human research.
Wow. So I've used the term graviception so many times, looked at the vestibular system, but I'm not a neuroscientist, and I did not know that. I did not know that there's no primary cortex. Like, it's obvious. I've never talked about a primary cortex for the vestibular system, but I didn't know that. That's incredible. I think, Brennan, that almost changes the way I think about it, that it is
well, it kind of stands
unique,
to reason,
it's different.
right?
Yeah.
I mean, it stands to reason because the vestibular organ, the vestibular system is so fundamental to embodying yourself into a body. And the reason that you know in part that you are in your body and not in my body is that when you move your head around and your body around, your vestibular system is telling you that your mind and body are connected as one. I like to think of it as the glue that holds mind and body together in a way. So it would make sense that it would project broadly and not to a singular center. But this is me being a little bit poetic, so I'll let the expert weigh in on this.
Oh, I absolutely love your definition of the glue done by the vestibular system. So it's unique in many different ways. So it's unique because it doesn't have a unimodal vestibular cortex, but it's also unique because it doesn't produce any phenomenological experience. So if you think about vision, you have a clear, identified sensation related to visual processing. The same for a sound. You can perceive a sound. There is a phenomenological experience. Or a tactile stimulus on your skin can also produce a phenomenological experience. You immediately know there is a mosquito on your skin. But for the vestibular system, it's different. Actually, you start to become aware about vestibular related sensation when something goes wrong. when you are on a roller coaster, when you feel vertigo, when you have dizziness. But those
Right.
are not a necessary vestibular signal. There's something going wrong in vestibular processing because each movement of your head is not really consciously perceived, or gravity is not consciously perceived, as we do consciously perceive every other environmental signals.
That's amazing.
Yeah.
Again, you're blowing my mind. Like, have talked about consciousness in relation to gravity, but you're saying that it's mostly unconscious until something goes wrong. It's in sort of a mismatch with another sensation, a visual or a gustatory, some other mechanosensory system. So it's working in combination all the time. So that's really the first question we had is, how does the body sense gravity? And if the vestibular system is so central to that, I heard yesterday that it actually develops at the 11-week mark during gestation, that it's mature that early on. Then how does it actually create a sense of gravity in combination with everything else? How do we build that representation from, it sounds like it's almost something abstract, that we're not sensing it directly or perceiving it directly?
Absolutely. So we do not have one single gravity receptor in our brain, in our central nervous system. So what the brain does is integrating information from different sensory sources in order to build up a representation of terrestrial gravity. So the main players are the vestibular one, and in particular the vestibular otoliths. Those are receptors in the inner ear that get stimulated and therefore sending neural signals as soon as your head is not longer upright. So if I'm upright and I'm not moving at all, these vestibular otoliths are getting a little bit silent, but as soon as I move my head, and in particular, as soon as I tilt my head in function not longer aligned with the direction of gravity, there is an action potential, a neural signal that is triggered by the vestibular otolith. So we have the vestibular system. Then we have the visual system that also can contribute in identify what is the direction of gravity. I always give this example. Think about going back home and suddenly realize that a frame that you have put on the wall is not vertical. I always have this sensation of, there is something odd with that frame. It's not really aligned as I would like to be. And that's because your visual system knows what is the normal direction of gravity that we call indeed verticality. That's not enough. We also have proprioceptive information that contribute to the computation. So proprioceptive informations are all the sensory cues coming from joint muscles in order to tell us where are our different body parts in space. And that obviously contributes to know whether we are aligned or not to the direction of gravity. And last but not least, visceral information. So information from our visceral organ. So now the brain is receiving all these sensory cues, and what it does is integrating them in order to build up a representation of terrestrial gravity that we like to call an internal model of gravity based on the reliability of these sensory information. So the strongest are the cue, the most reliable are the cue. The brain likes to trust them and therefore integrate that in this computation.
And that obviously
I'm
happens.
going to jump in for a second, Lachlan, because some of our listeners may have heard of, the homunculus, which is sort of the little man, so to speak, little person in our brain.
The very famous Penfield homunculus.
Yes, it's the sort of weirdly shaped, man with oddly large hands and big lips and face, and that's a representation of how the sensory system is represented in the sensory cortex of the brain. And, for each part of the body, we can locate, like you said, if you get stuck by a pin in your finger, you're going to feel it in your finger and so on and so forth. It gets a little bit more difficult with the gut and the viscera because that tends to be a little bit more broadly represented in the sensory cortex. But you generally know your stomach's hurting, might radiate to your shoulder, to your back. But what I'm hearing is that the vestibular system is unlike all of that, because there's no part in the homunculus that the vestibular system projects to. So it's almost, and you're also sort of using computational language, like, as if there's some kind of a program running to keep track of gravity using all these different sensors. So I'm starting to get the picture that gravity has certainly informed our sense of it by all of the bits that make up the homunculus. But then there's some kind of an integration system maybe that works across the whole homunculus. That's why I call it the sort of glue that holds it together. And if that's broken, either because you have an otolith bouncing around in the middle of your ear, like I've had before, which is very, very upsetting to feel dizziness like that, or you have some inflammation or all sorts of conditions that could affect the inner ear, then your computer processing, we'll call it, if we use that analogy, is thrown off because the whole, I don't know what the analogy in the computer is, but the whole thing is being thrown off. So what do you make of that interpretation of what you're saying?
Yeah, I think that's pretty accurate. I like the idea of, how you highlighted the importance of the computation of this sensory signaling. So the way in which we think about that is looking at all these different sensory channels. Every sensory channel is associated with reliability of the signal. So how strong is a certain signal? How accurate is the signal? How noisy is that channel? And in function of this reliability or strength, you can think about creating an equation that is combining all these different sensory modalities. So is basically taking different channel, each channel associated with a strength, and in function of the strength, building up a computation. Now, this computation is what is creating the internal model of gravity. By having said so, we can also think about the fact that we have always been exposed to 1G. So terrestrial gravity, 1G, is probably the most common environmental feature that we come across in our life, and also throughout evolution. So on one side, we have the ongoing online sensory cues that are reaching the brain. On the other side, I like to believe that we have a prior, some knowledge, some semantic knowledge, some experience-related knowledge that tell me that, yes, you are an environment in which there is 1G, and therefore I can rely on this prior model that I've built up. All the sensory information line up very nicely, and therefore the job for the brain is pretty easy, well, kind of easy.
Do you think that this might help explain why the vestibular system matures so quickly in a fetus? Like the 1G has been present from the moment of our conception to the day that we end and give in to gravity. And that sort of needs to be laid down first before the other sensory systems kind of fill in underneath it.
Yes. So in some of my papers, I've written that the vestibular system is fundamental and foundational to human behavior. And the idea that it's foundational is because it's really setting the foundation in order to shape all our behavioral experiences. And what are these foundations? The foundations are with gravity. The foundation are the fact that I'm in 1G environment and I need to interact in this 1G environment. So it's the most basic signal that our brain needs to deal with from day one.
That's incredible. And I think that you just used a word before, the semantic knowledge of gravity that's almost inbuilt, like neurobiologically, because we're talking about this, the physiological side and the physical side, but there's so much gravity in our language as well, and in meaning and in purpose and in spirituality. Like it's everywhere in our lives. It's not just this physical experience. Elisa, what do you think about that extension of gravity? It's of graviception. It's a computational element that we can then use in semantics as well. We use it in our language. How do you view that as coming about? Is it just a natural extension of cognitive beings? Is it just cognition across the spectrum and emotion?
And it's interesting that you are asking me that. And can I highlight that we didn't agree about this question, or we didn't set up this question before? It's very interesting because we are currently running with one of my PhD students some experiment looking at the semantic aspect of gravity and the fact that words that portray bad connotation of gravity are pointing down, heavy, while others that are more positive related are upwards related. So yeah, it's something that you need to invite me again in a few months to tell you about the result.
Yeah,
because it just started. But a few years ago, we have done some work looking at the aesthetic of gravity. And it's pretty much in the same line that you are talking here. So in vestibular research, we like to use verticality tasks. So you present hundreds of lines that are either upright or tilted, and you ask participants to judge, are these lines upright or tilted? And you do that in a occluded visual field, so there are no other cues from the environment. The only thing that the participant can see is the line, and they need to judge whether it's upright or tilted. And we use that, I would say, every day. Now, at some point, I started to think about, what about the aesthetic? Do we like objects that are aligned with the vertical more than objects that are not aligned with the vertical? So we have run experiment in which we ask participants, our poor subjects, to judge how much they like different inclination of the lines. And then when you look at the data, you see that there is a strong, significant preference for vertical lines. And yes, they are just lines, okay? So nothing aesthetically really pleasant. But then we tilt the body of our participants off of gravity in different orientation, and we found that this preference was not longer there. And also we have run further control to show that it's not just how the line are going to appear on the retina, but they seems to be more related to vestibular processing and congruency between your own body and the direction of gravity. Now, it's not a novel idea, because if you think about art or architecture or very tall building that we have here in London City, so why we are so into portray tall vertical things, and also why we are so interested in the connotation of power on a vertical way.
Yeah.
You see what I mean? So
I
think it's related to this in very close relation that we have with gravity, and how the physical aspects of gravity actually goes into our cultural aspect as well.
Yeah.
Does it make sense? Or I'm just blah, blah, blah.
It makes perfect
Well, actually,
sense.
not only does it make sense, it's the basis behind Lachlan's theory, in a way, of mental gravity, that up is good and down is bad. And there's a reason why cathedral ceilings are so high. Or when you enter New York City, in Grand Central Station, you feel like you've been escorted into the city like a king. But if you come in to Penn Station with these low ceilings, it's been said that you scuttle in like a rat. And so there is a very strong relationship between the verticality of our physical environment and our mental environment. And so, this is definitely a very important concept, one that I know Lachlan's written quite a bit about and thought about as well.
And other people are writing about it as well. There's Thomas Fuchs in, I think he's in Germany. He's a phenomenological psychiatrist, and he talks about this somatic continuum, that there's the meaning and the shared meaning that we create in daily life is not just embodied, it goes beyond embodiment. It's not all just a physical sensation. Some of it is, like you say, it's that prior mental, semantic, almost inborn concept that we have of gravity that's there, that's threading it all together. It's not something that we explicitly say, oh, I'm doing a gravity thing right now, but it's in all language, it's in all architecture, it's in all art. It's there as the glue that's making it all make sense, for sure. So that takes us to the mental life. But what about emotions in particular? How does the vestibular system and graviception lead to those feelings of fear and calm and excitement and nausea? And where does it all come from? Why is that mismatch between the vestibular system and other sensations? Why is it so emotionally charged?
Yeah, so there is a direct link between vestibular projection and area in the brain that are in charge of emotional regulation as well as autonomic responses, such as flight or fight response. So anatomically, some of these vestibular signals that we say travel from the vestibular organs to different brain areas are going to reach directly some of these areas that we know are in charge of emotional processing, amygdala, the insula, as well as some related to emotional expression, such as the hypothalamus. So it's not surprising that vestibular symptoms, dizziness, vertigo might be highly associated to very strong emotional responses. But on the other side, you can also think about the vestibular system as this foundational signal that help us in protecting ourselves. So all these projectors that are going to very basic subcortical structures, such as the hypothalamus, might have a very close link to survival. So when you get nausea, when you get sick, in terms of, vestibular sick, such as you have been in a roller coaster or suddenly the usual gravity is not the same, such as in space or during parabolic flight, is a very strong signal for the brain to process. And there might be protective mechanisms, such as the one triggered by nausea, dizziness, vertigo, that make the organism be aware that something strange is happening to them.
So you've done parabolic flight, haven't you? You've been in an aircraft and you've felt that sensation of weightlessness. How was it?
Oh, I have done the vomit comet, and I'm very happy to confirm that for me is always the vomit comet. It was the first flight until the one that I've done a few months ago, and I'm going to have another one in April, and I'm pretty sure it's going to be another vomit comet. So I'm an expert in using the vomit bag.
So the social media post is just you before or after, not during.
Oh, yeah. It's I'm learning with experience how to be fast, and that's a big achievement. But yes, for me, it's weightlessness. It's the most amazing experience that I've tried in my life. And I'm not here to sell it to you. It's just fact. For me, it's the most beautiful thing that I've tried in my life. And if you don't mind me say, I think it's a little bit addictive. So
really,
I feel that I wanted to do it more and more and more. I can wait to be on that flight, and then I'm incredibly sad after the flight. Because I know that it's not something that I can do.
Well, you mean you're feeling down after the flight? Is that the idea?
Yeah, so, I do.
Literally floating high, even buoyant. We talk about feeling. You're on psychedelics. You're high, and you're low and down when you're back on the ground.
Look, I know that I might sound crazy, but that's how I feel. It's exactly like that. It's building up expectation. Also, it's challenging. There is a lot of adrenaline related to seeing your experiment working in the parabolic flight. And then the floating, the environment, and then it's over and I go in the down phase. So the days when I come back from parabolic flight is not easy for my colleagues to have me around.
Is it something are you just paying to do it yourself? Is it through work? Is it for research? Are you just doing it for your own interest to live what you're practicing?
So it's related to my research. So I have European Space Agency funding that are supporting my research, and part of this funding is for a parabolic flight campaign. So we take our experiment in the parabolic flight, and we collect data pre, after, as well as during parabolic flight.
So, do you need any other subjects as well? I'm sure we're both volunteering to do it ourselves, Brennan, or you don't want to do it. We've been on roller coasters together. Maybe we shouldn't.
Well, it's interesting to me to reflect on this notion that floating is addictive, or among the most, incredible, sounds like, physical and emotional experiences you've had. And I think about how from the moment we're in the womb, we talked about earlier, to the end, we are constantly standing up to gravity. Our goal in life is to stand up and stay up as long as we can and as well as we can until inevitably we're pulled back down. And ultimately, in some traditions, we end in the ground in a gravity box called a grave, which I've said before is derived from the word gravity, same etymology. And so the opposite of having to fight and strain and exert and pump and calibrate is to just give into it completely, but still be alive. And that's what floating is, it seems to me. And I can see how it would be addictive, because you, for once in your entire life, are fully and entirely released from the 1G field that we're all born into and are designed to essentially fight and hopefully harmonize with if we're successful, until eventually we can no longer. So it's, again, a little poetic turn of phrase, but that's what it sounds like to me.
And go back pre-birth. It's the sort of condition of the embryo during development. It's in a state of neutral buoyancy water in the womb. It's not feeling any of the downward pull. It feels buoyed and sort of weightless. You know, if by 11 weeks old, if we've got a vestibular system, I don't know if we're actually feeling weight, but there is obviously some potential.
Yeah, but there is an up versus down, just like fish and water have a vestibular system, right? And they need it so foundational that I would think, I don't know, I'd be curious, sort of comparative biology, what other types of creatures have, vestibular systems and why. That's a whole other direction to go in. But we have that in common with a fish, that we do need to know up versus down at that early stage, even if we're buoyant. Anyway, we're going in lots of directions. So what do you think of all that?
So I would like to go back to your point. And I often say that the sensation during parabolic flight and wellnesses and flotation, it's freedom. So I feel this incredible freedom during that experience. Having said so, this freedom doesn't come with no cost, because it's very challenging for the body physiology and for the brain to cope with the absence of gravity. So it's not something easy for us to do, because we are set for 1G. So it's interesting how, despite the fact that sensory conflict might happen during parabolic flight or in zero gravity, sensory conflict means that suddenly the vestibular organ are not able to tell anything about gravity, and that's a unique condition that we are really not used to. And then all the integration that I was talking at the beginning of our chat between vestibular, proprioceptive, and somatosensory, as well as visual and visceral organs signals, is going to be a little bit crazy, because the comfort of the usual gravitational signal is no longer there. So it's freedom that is coming with a cost, and the cost is how long does the brain learn how to recalibrate in this new zero gravity environment. And we know that not only from subjective experience on parabolic flight, but for years of research, as well as the experience of astronauts. So the first hour, days, and sometimes weeks are very, very challenging for astronauts. They encounter the so-called space adaptation syndrome or space motion sickness, which is basically driven by this sensory conflict, the conflict between vestibular, visual, proprioceptive information. What are the consequences? Nausea, vomiting, brain fog, disorientation, poor sensory motor coordination. And that's probably why, we know it's one of the reasons why they are not allowed to do very challenging activities, such as extravehicular activities, the spacewalk, when they are at the beginning of the space flight. Do they adapt? Yes, because something that is fascinating about our brain is the ability to adapt to extreme conditions, such as space. So it takes time, it takes resources, but eventually neuroplasticity happens and we adapt to these conditions.
So that's like the glue has to reset the structure. It gets broken by the conditions, but the vestibular system has to come in and re-glue it all, and we can do it thanks to neuroplasticity. But something you said there about that sense of freedom and there being a cost. I don't know if you heard our episode with Harmon Clark, which is one of our favorites, where he got that feeling for free in VR. He got that sense of feeling of freedom while he was very unwell, and he said, I want to get that naturally. And he then did yoga and exercise and diet, and he worked at it, and he says he gets that feeling now outside of VR in real life for his own mental health and well-being. And I think that's kind of the underlying goal of biogravitational medicine, is to encourage people to take those little steps exercise, diet, whatever it is, not just lifestyle, maybe, mental stuff as well, mindfulness, whatever channels are available to you to get that sense of freedom, but at acknowledging the cost. It takes work. It doesn't just come for free.
So really, as I'm listening to you, I'm thinking, how do we make it to Mars? Because we've just talked about how our bodies are so perfectly, utterly calibrated for 1G, because that's all we've known. It's all we've known. Every part of our body, every muscle, every sinew, every cell, every tendon, every otolith, every single part down to a microtubular level evolved to manage this fundamental force. And there's only one other that we're really managing, that's electromagnetism. So if we're so perfectly calibrated, and that all it takes is a parabolic flight to change your mood for a few days, much less to be in space, how are we going to make it to Mars? Now, neuroplasticity sounds like the answer, at least neurologically. And then there needs to be a similar plasticity to all the pumps and tubes and piezo channels and every single thing up and down the human body. But is it actually reasonable to think that our ability to adapt is good enough that we can overcome being perfectly evolved for this place and not that place? How are we going to make it, even if our most strongest members of our species who are selected to go into low Earth orbit are getting headaches and nausea and abdominal pain? What happens when regular people try to go out into Mars?
Well, I believe in adaptation. I believe in the ability of our body and brain to redesign itself in order to adapt to environment. And that's a very basic factor for survival. So I'm not saying that it's going to be easy, but I do believe in us living on Mars in a way or the other. And over generation is not going to happen overnight, but over generation, the perfect body that we have now here on Earth is going to transform itself in a perfect body for Martial gravity, 0.3G. And then we might have trouble in coming back home and visit our family once we are there on Mars. But
that's
I
profound
think that,
because I'm sorry to interrupt, but our body, of course, has evolved over, thousands, tens of thousands, millions of years, right? And in evolutionary timescale, we're talking about, a nanosecond. We're in Mars, and we've completely changed all of the reality that our body's ever known. Although there is some gravity there at least, and maybe we can have artificial gravity on the way there. But you feel that we can adapt that quickly, even on that kind of a time scale, to such a severe change in circumstances?
I think we have the potential to do that. I think I'm talking about the brain. So
yeah,
I'm not qualified to talk about mitochondria or any other thing.
Yeah, bone density, all these things. Yeah.
I'm just talking about the brain, and I think in terms of brain plasticity and adaptation, and also what we know how we could potentially boost brain plasticity with brain stimulation or other methods. I think there are potential.
Oh, that's fascinating.
And just by looking at what we have done in my research, we found that, yes, we have this model of gravity that is perfect for 1G. We make the most of it when we are in 1G, and then it takes time for us to adapt to different gravity environment. We have also shown that this model is probably innate, because we have done some animal studies showing that there are predisposition for 1G acceleration, but also we found that it's not selectively related to 1 as a number. So we've managed to have adaptation to 0.3 in terms of brain adaptation, as well as having participants in VR environment here on Earth and making them interact and learn about 0.3G or lunar gravity quite easily. As far as there is not a big sensory conflict. If there is a big sensory conflict is where the troubles come in, and that's why I believe that all our efforts should focus on how we can speed up adaptation and how we can rid of this big sensory conflict.
All right, well, we've gone out to the far reaches of space. Let's bring it back down to Earth for the everyday listener. What do you have like a vestibular graviceptive tip, Elisa, for listeners? Is there something that you do? Are you conscious of your vestibular system? Do you think about your posture? Do you think about breathing? Do you think
I
about
try.
head rotations? We all do. Okay, let's all sit up. Is there something that you do that you actually have applied what you've learned in your research to your everyday life for your health and well-being? Is there something that you think about?
Yes, and I like the idea of feeling grounded, and I like the idea of the security that gives me mentally when I feel grounded. Now, how you do that, there are different ways. I practice yoga personally, so I like the feeling that I have when I'm focusing on body posture, keeping the body posture, and exploiting gravity in order to reach certain body posture. But potentially you can even stand on your feet and appreciate the force on the sole of your feet and feeling grounded on a secure environment. And I think that would be a very simple exercise to do in order to reshuffle all the bodily sensation and make a clear appreciation of what is gravity and feeling secure. Because it looked to me, or from what I know from my research, is that our brain does like the secure aspect of 1G.
Yeah.
So appreciate that. Feeling grounded might help a lot in decreasing anxiety, reset expectations, and have a moment for self-awareness.
That's wonderful, because I think highly sensitive persons, people with autism spectrum disorder, use a weighted blanket to get that feeling. So they actually use gravity actively, not just passively through our own body, but actually use it as a tool. And I think we can do the same thing mentally as well. I'm running a study at the moment on heavy music as a weighted blanket, as an analogy that there are gravitational, acoustic sensations as well. You say it's, a multisensory thing. So there are multisensory ways to get it. It's not just, I do yoga as well. And the breath is a big part of that as well. The grounding to the breath, feeling, like you're centrally located and focused on the breath. That's wonderful. Elisa, thanks for joining us.
There's a reason why we call it Mother Earth.
Yeah.
Right? That's the source of the 1G. It's this planet from which we emerged. That is the source of our design, if we want to call it design. Our evolutionary history is entirely constrained by the physics of our reality and the physics of this planet. And it makes sense to essentially acknowledge and honor that 1G field as the only thing that we've ever known, the major source of our structure and function, and to lean into it almost literally, whether it's through yoga, through, inverted poses to, flood the brain with blood, why we sleep at night and reperfuse our brain overnight. There's so many ways that we physically orient ourselves to 1G for our benefit. And as long as we can stand up to it and be strong enough and have the fluidics in our body and the tensegrity in our physical structure to bend without breaking, thinking about it as a source of comfort, and to understand, as you've said, that neuropsychologically it is a source of comfort because it's what we know, makes a lot of sense to acknowledge that in our everyday lives. And yoga is maybe just one way to do that.
Yeah.
Well, Lisa, thank you for joining us, and we'd love to have you back again, or I personally would, when you get the results from that study, the Semantics study. That'd be amazing. So thank you. We really appreciate it. We'd love to have you back again.
Yeah, thanks for joining.
Thank you.
If you liked that episode, please like and subscribe and tell your friends about the Gravity Doctors. You can also follow us on social media. Check out the book Pull, and you can also check out our show notes for tips and links to some of our scientific articles. You can follow us online at thegravitydoctors.com. You can follow me, BrennanSpiegelMD.com, and Dr. Lachlan at lachlankent.au.